Part 3, Fractional Exponents and Radicals. In grade 9, you learned that for powers with integral bases and whole number exponents, that a to the m times a to the n, you can simplify that to one base and add the exponents. So something like you had before, so x squared times x cubed was just x to the fifth. We've actually used that last chapter in chapter 3. Okay, so that's nothing new to you. But now we're going to extend this law to powers with fractional exponents. We're going to start with the numerator being 1. So let's consider the following. So 5 to the 1/2 times 5 to the 1/2. Okay, awesome. So the thing is, we can combine that to 5 to the 1/2 plus 1/2. Well, a half plus a half is just 1. So that ends up being 5 to the 1, which of course is just 5. Okay, well, we can, if we have a look at this part now, we can say the square root of 5 times the square root of 5 is the same as the square root of 25. Okay, easy enough. And the square root of 25 is just 5. There's an interesting consequence from this. From the above, we can see that 5 to the 1/2 then is really just root 5. Okay, so there's a rule here, powers with rational exponents with the numerator 1. When n is a natural number and x is a rational number, so a fraction, okay, so x to the 1 over n is the same as the nth root of x. So basically the idea is this number, this denominator in the exponent, that really is just the index on the radical. Okay, so if we had something like the cube root of x, okay, so this index on the radical is the denominator of the fraction on the exponent. Excuse me, goodness. Okay, so we end up with x to the 1/3. Okay, so the cube root of x is the same as x to the 1/3. Okay, awesome. All right, so evaluating powers of the form a to the 1 over n. So these you're just going to type into your calculator. So I'll show you how. It's the same on both kinds of calculators, the TI-84 families or 83 families or the TI Inspire. So you use the little hat button or the caret button. Okay, and then instead of typing in like a 2 or a 3 or anything like that, so you just go 1 divided by 3. Okay, so that's going to be 1,000 to the 1/3. Okay, awesome. So this, of course, is the same as the cube root of 1,000, which is 10. Okay, so again, I'm just looking for you to type this into your calculator, but you can get this the other way. Okay, so a 1/2 exponent is the same as a root, so 0.25. Well, the square root of 0.25 is 0.5. Again, you just type it into your calculator, you get it. Okay, negative 8 to the 1/3, that worked out to negative 2. And then 16 over 81 to the 1/2, that's going to be 4 over 9. Okay, now, you can do this one in pretty short order as well. So the 1/2 we've learned is a square root. So again, you just square root the top of the fraction and square root the bottom of the fraction, so that's 4 over 9. So you can do this in your head for some of these numbers. For others, it's just you just type it in. All right, next one. A fraction can be written as a terminating or repeating decimal, so we can interpret powers with decimal exponents. Okay, and so for example, 0.2 is 1/5. So 32 to the 0.2 is the same as 32 to the 1/5. Now, if you knew that 0.2 was 1/5, then awesome. Good on you. That's perfect. Not everyone knows that. And that's fine. It's not a big deal. But you can use your calculator to help you transform those decimals into the fraction so that we can see what the index on the radical is. Okay, so how we do that on the TI-84, if we go 0.2, then hit your math button. Okay, math button, and then the first one in the math button is frac. So we go math, then frac, then enter. Okay, you might have to enter twice. I can't, I'm not 100% sure, but either way, math, frac, and then this will give you 1/5. Okay, on a TI Inspire, and okay, help if I spelt it right. Whatever, Inspire. There we go. Okay, under this one, you would go 0.2, and then you're going to hit the menu button. Menu, there we go. Menu, and then it's under the number, so that's the second one down. And then the second one in that sub-menu is approximate to fraction. Okay, scroll down and hit that one, and then enter. Again, possibly enter twice, not a big deal. And either way, that'll show you the 1/5 again. Okay, so on the Inspire, you can actually go menu to 2, enter. Okay, that would work as well instead of scrolling. So menu to 2, okay, and you would get the 1/5. Okay, so you can see that 0.2 and the 1/5 is exactly the same. So of course 32 to the 0.2 will equal 32 to the 1/5, which of course is 2, by the way. Okay, so that's that one. So what about fractions where the numerator is not 1? Okay, so when m and n are natural numbers, or are natural numbers, and x is a rational, so any kind of fraction, okay, decimal, whatever. Okay, so the idea here is n is still the index on the radical. M is the exponent, either on the radical or on the base. So m is the exponent, n is the radical. Okay, and now because exponents are done on the same level of bed mass, okay, radicals are really just a level of exponents. So I can put the index first, so the index or the nth root of x, okay, in brackets all to the power of m. Or I can have x to the m, I can put that exponent on the x and then take the root of that. Now, in my humble experience, I have figured, or it's always best to do the index, or this one, the first one first. It makes the base smaller, because I don't know what 81 to the third is, but I do know what the square root of 81 is. The square root of 81 is 9, and then 9 to whatever exponent. So if you do the root part first and then the exponent, it just makes the numbers a little easier to think of. Okay? Either way, it's not a big deal. Okay? So example 2 is all about rewriting the powers in radical and exponent form. Okay? So this one says write 26 to the 2/5 in both radical forms. Okay, so the important part is the 5 is the index. So this is going to be the 5th root of 26 squared. Okay, so that's the one radical way. Or I can go 26 squared all to the 5th root. Okay, they are both equivalent, and it doesn't matter on your calculator. You can type it in either way. You'll get the same answer. Okay, B says write that in exponential form. Okay, so remember, when you just have a square root sign, the index is a 2. So really, this is 6 to the 5 halves. That index on the radical is the denominator on the fraction. Okay, and then for C, the 4th root of 19 cubed is the same as 19 to the 3/4. Okay, so that is the best way to write that one. Excuse me. Okay, next page, example 3. Evaluating powers with rational exponents and rational bases. So 0.01, okay, to the 3 halves. If you just type that into your calculator, you get 0.001. That's it. Done. Okay. The 4/3, negative 27 to the 4/3. Again, you can just type this into your calculator, you get 81. But let me show you how you can do this in your head. So the 3 on the bottom means cube root. So the cube root of negative 27, that's negative 3. Okay, and then negative 3 to the 4th, because that's what the 4 means, is the exponent. So negative 3 times negative 3 4 times. Okay, well, that is just positive 81. Not so bad. Okay, again, if you do the root part first, okay, it just makes the number smaller and easier to deal with. So for C, we could go 81 cubed, take that answer and 4th root it. Okay, most of you are just going to type that into your calculator anyways and get 27. Okay, not a problem, you can do that. Okay, but if we look at the 4th root of 81, 4th root of 81, it's supposed to be cubed. Okay, so 4th root of 81 is 3, and then 3 cubed is 27. So we can do that in our heads if we want to. Okay, and then decimals in our heads, that's just a bad idea. Okay, so 0.75 to the 1.2, that is 0.708. Done. End of story. Okay, example 4, applying rational exponents. So biologists use the formula B equals 0.01 m to the 2/3 to estimate the brain mass, B kilograms, of a mammal with a body mass of m kilograms. So estimate the brain mass of each animal. So let's say a moose has a body mass of 512 kilograms. So its brain then is going to be 0.01 times 512. So when I substitute, I actually put brackets around that just so that I know that this is what the m was. Okay, and then to the 2/3. So we just type this straight into our calculators. So 0.01 times, whatever, times 512, little hat guy, 2/3. So that'll get it for you. Again, you don't have to show that. It's just this is how you type it in. So 0.64 kilograms. Awesome. Okay, what about a cat with a body mass of 5 kilograms? So B equals 0.01 times 5 to the 2/3, which is 0.029 kilograms. Okay, so that is it for this part. I need you to practice this material by doing section 4.4. Starts on page 27. Again, it is best if you print out the sheet from the workspace card. Then you can write all over the questions. If you don't want to do that, that's fine too. You just have to use loose leaf. Either way, remember the answers are in the back of your book, so you can check them. Okay, and make sure you show your teacher your progress before you go on to the next lesson. So good luck on this stuff. We'll see you next part. Thanks.